Hey again, everyone. I'm going to look at number 1 in section 4.1, doing a little linear approximation. Copy the problem down here. It said to estimate the change in the function using linear approximations, and then you're going to use your calculator to compute both the error and the percentage error. So we'll take a look at how to do that with the calculator. So this particular example has the function the square root of 8 plus x. The value of a is 5 and delta x is 0.4. So our approximation for the change in f is this linear approximation. This is basically moving along the tangent line, right? Tangent line has slope f prime of a times the corresponding change in x will give us the corresponding change in y. So I do need the derivative. I rewrote the function, right? 8 plus x to the 1/2 power. Derivative is by the chain rule. Derivative of the outer function, u to the 1/2 is 1/2 u to the negative 1/2 times the derivative. Well, the inner function is 8 plus x times the derivative of that inner function. Well, the derivative of 8 plus x is just 1. And so just rewriting this, 8 plus x to the negative 1/2 becomes 8 plus x in the denominator to the positive 1/2, which is the square root. So here's my derivative. And then I'm going to plug in a f prime of 5. And I get 1 divided by 2 times the square root of 13. That's f prime of a times delta x is 0.4. And so I do 0.2 divided by the square root of 13, which I've done over here in my calculator and got this value. They wanted you to round it to 7 decimal places, so you don't want to round to the end. And so 7 decimal places, that second 0 has a 1 after it, so I will not round. I keep the 0 the same. Then we want to look at the error. So first of all, what is the actual change? We've estimated this change. What is the actual change? Well, we're going to use the calculator to do that. The actual change is f of a plus delta x minus f of a. Again, a is 5 and delta x is 0.4. So a plus delta x would be 5.4. F of a is f of 5.4, excuse me. And then over here, f of 5. And so remember the function f of x is 8 square root of 8 plus x. So 8 plus 5.4 is 13.4. So you take the square root of 13.4. And of course, f of 5 would be 5 plus 8, 13 square root of 13. So I subtract these, again, using the calculator. And the actual difference is that. So you can compare the actual change with our approximation. Pretty good. We're pretty accurate. It looks like to almost, to the third decimal place, and then we start, getting off. But a pretty good approximation. What's the actual error? So the actual error is just the difference between these quantities, well, the absolute value of the difference. So it doesn't really matter which way you subtract, just take the absolute value. So I took this thing, subtract this thing, and I did that again in my calculator. And I did it in my calculator too, because you might get a display like this and you need to understand what this means, right, in the calculator. So this number is not 4.2. This e to the negative 4 means basically times 10 to the negative 4th power, which is really dividing by 10 to the 4th, which means this decimal place is going to move. Oops, my calculator died on me. Which this decimal place is going to move, 4 places to the left, right? So past the 4, and then 3 more spaces I need to put in zeros. So 0.00042 is the error. They wanted you to round it to 5 decimal places. And so that's what we rounded it off to. That is the error. And then what is the percentage error? So percentage error is you take the error that we just found relative to the actual change. So we're going to take this error and divide it by this, and then you can convert that to a percentage. And again, absolute value around that as well. And so all I did was took that value and just divided it by that quantity. Since they're both positive, we get a positive result. This is the percentage change. Well, the percentage change rather would be as a percent. Of course, you just move, multiply by 100 basically means just move this decimal place twice, point, right? Boom, boom. So 0.76, they wanted you to round it to 2 decimal places. So 0.76%. I think in Achieve, you don't need the percent sign. They're assuming it is in percentage per 100. Okay, so this is less than 1% error in this approximation relative to the actual error, and so pretty darn good. Linear approximation, pretty helpful. in a lot of settings. So hopefully this problem makes sense. It's pretty easy, but there's a lot of parts, and let me know if I can help in any other way.